Hi, I'm James. I'm going to speak to you today about breaking changes. For context, the background that I come from is web development, so I'm in the JavaScript and Ruby ecosystems mostly. And although this talk is going to focus on JavaScript, which suffers from some of the problems in this talk quite acutely, those problems also exist in other language ecosystems to greater or lesser extent, depending on the semantics of your language and what kind of tooling you have available. So hopefully this will go over depending on what kind of programming background you come from. So the context of this is that so I've been maintaining open source software for quite a while. So roughly since Node.js came out in 2010, I've been maintaining this WebSocket messaging product called Fei. That has spawned several sort of smaller libraries that have been extracted from it that deal with various layers of the WebSocket protocol. And those have now been adopted by quite a wide array of different projects. So this is now used to power the WebSocket stuff in Rails and in Webpack. So these are downloaded sort of several million times per week. And so this comes out of my experience maintaining these over that span of time and sort of seeing how things that they depend on change over time and how people are using them, and trying to reflect on that process of change and the human factors involved, and not just looking at versioning from a sort of purely technocratic perspective. One other bit of context is that any open source license that you use for your software will say something like this: the software is provided as is. None of what I'm saying should be construed as a complaint about how everybody's doing it wrong and it's really bad. I'm really trying to reflect here on how we could do things a little bit better rather than sort of pointing the finger at anybody. Okay, so if we're going to talk about breaking changes, we should first try to define what we mean by that. It's a word that gets thrown around a lot without a lot of precise definition. So, for example, let's say that I have a module shown at the top here called HTTP, and it has a method called get, and that takes a URL and a callback. And it makes an HTTP request to that URL, and then when you get a response, it calls your callback with the status code from the response, which I've hard-coded here as a number. Now, let's say that we make a change to this module by just replacing that number with a string. We want to decide whether that change should be considered breaking. Do we want to release a new major version because of this, or is it a bug fix or something the user won't even notice? So we need to look at some use cases to decide this. So let's say a caller exists for this module that is checking the status code by using JavaScript's double equals operator, which is a sort of loosely typed equality operation. In particular, it treats numbers and their decimal representation as being equal. So if somebody is using the double equals operator with this code and we replace the number with a string, that will keep working and having the same effect. However, if we're using the triple equals operator, which is type strict and does not consider numbers to be equal to strings ever, this program would break. And the author of this program would consider the change to the HTTP module to have broken their code. So here's another example. Let's say I have a module called database, and it has a method in it called count, which takes the name of a table and a callback, and makes a SQL query to count the number of records in that table. And it returns the result back to you via a callback, again passing the count as a number, which I've hard-coded here. Now, something about this module that is worth pointing out is that this is structurally identical to the module that I just showed you. All that I've done is changed the names, but from the point of view of stuff the compiler cares about, this is the same program. So if we decided that the change to the HTTP module was a breaking change, and if we consider that the questions of compatibility are only about examining the source code itself, we ought to give the same answer for both of these modules. So, is this replacing a number with a string in this module considered a breaking change? Well, again, it depends what the user is doing with that code. So, somebody might be wanting to find out how many tickets are remaining for a conference, and so they'd count the number of purchases in one table, a number of tickets from another table, and subtract the two. And JavaScript, the minus operator, if you give it 2 strings, it will convert those strings to numbers if possible, and then do arithmetic subtraction on them. So if you're subtracting these 2 values, this program will still keep doing the same thing if you replace numbers with strings. However, if you're adding 2 things together, for example, trying to work out the total number of sessions at a conference, JavaScript's plus operator sort of does the opposite thing. It tries to convert everything to strings first. So if you give it, or rather it's overloaded. So if it's given numbers, it performs addition, and if it's given strings, it performs concatenation. So rather than getting 5 here, we now get the string 3, 2, which is not the same result, so this program has changed its effect. So the change to the module has broken this program. The author would need to make some changes to their code to convert the strings back to numbers so that they could deal with them in the way that they wanted. So what we've seen here is that the meaning of values in programs is not just about their concrete type in and of themselves. They have to be looked at in context. How are they being used? And in particular, like what roles are they playing in a program? So even something as simple as a number has various sort of characteristic traits. So in the Haskell community, these might be called type classes. Java users might use the term interface. But they embody this idea that values have several distinct capabilities that they can be used for. They can take part in multiple different operations depending on what properties they have. It's not just that's a number and that describes the thing fully. So what are some properties that numbers have? Well, they can be used just for their identity, right? So HTTP status codes aren't like arithmetic numbers. It doesn't really make sense to add 2 status codes together. That doesn't give you a meaningful thing. They're really just labels. So all that you would do with them is compare them for equality. But you might also want to do arithmetic with numbers, like add and subtract them and so on. So these are two distinct capabilities that numbers have. So if something as apparently simple as an integer can have this much sort of complexity bundled up in it, let's look at something more complicated. Let's look at objects and what happens when you change the interfaces to them. So let's say I have a function called getTalkInfo that takes the ID of a talk and it returns some information about the talk. In particular, it returns information about this talk that's happening right now. So it has a title, a date, and a presenter, all of which are strings. So if we decided to add a new field to this object, it's quite likely that most callers wouldn't care about that. They just ignore the presence of this new field. And so they would carry on working. Yeah, most programs don't go and like check the entire interface of the objects they're given and complain if there's anything there they don't expect. However, if we remove a field, that's probably more likely to cause problems, right? So if we have some code that is calling that function and then getting the title property from the result and putting that into a string, we will get our program won't crash, so it will keep working. But it won't do what we expected. So this is a case where JavaScript, like you've made a mistake, but JavaScript doesn't throw an error. It's not an error to access a field that doesn't exist in JavaScript. You just get the value undefined. And undefined converts to a string by like that. So you won't find out by your program like failing to type check or it crashing that it's not right anymore. So yeah, our program is broken, but it's also very hard to find out that it is broken because the language isn't telling us so. Likewise, if you change the type of an existing field, that is likely to break existing callers because they'll be relying on that field and they might be calling operations on it that are no longer supported. So for example, if we had some code that was taking the date field and calling split on it to split it into its component parts, that will no longer work because date objects don't have a split method. You get a reasonably okay error here, so actually like calling functions that don't exist is an error, so that's good. Whether it's a type error per se is sort of debatable, but like you get reasonable feedback from the environment about why your program isn't working. So as a rule of thumb, it's usually okay to add new fields to objects. That tends not to break existing callers. Removing fields does tend to break existing callers because they will be accessing those. If they're accessing those fields, there'll now be nothing there for them to use. Likewise, changing the type of an existing value that a program is accessing is likely to break it. And these rules will be familiar to you if you're familiar with something like record subtyping. Like these ideas are where the usual ideas of how record subtyping works. You can add new fields to stuff and they'll be ignored. If you take fields away, that will probably break stuff, and so that won't type check anymore. So one problem that JavaScript has that makes it quite hard to deal with these sorts of problems is that by design it's a very small language. It has very few just different things in it that you can use. And those things are overloaded with several different meanings. So in JavaScript, the object class is used to model several different computational ideas. So they're used to represent maps. They're used to represent records. They're used for object-oriented programming style objects. And because there's only one thing in the language and it gets sort of overloaded with these different uses, it's hard to tell what somebody intends when you just see them using the thing. Pardon me. So what do these terms mean? If you just see an object in a JavaScript program, you'd have to sort of figure out in what sense is it being used. So one of those senses is that it could be a map, and by a map we mean an open-ended collection of key value pairs where the keys and values are usually all of the same type. When a program is using maps, it typically doesn't care about the exact keys that are present. It won't be accessing them by hard-coded names. It'll usually be iterating over them or accessing the keys in a sort of dynamic way, so the keys won't be hard-coded. So the map is just arbitrary data, and it's processed as such. A record is a value that has a specific known set of keys, and those keys are allowed to map to values of different types. So if your program is accessing specific fields in an object by name, and your program knows the names of the fields the object is supposed to have, using the object as a record. So the props that you would pass into a React component are a good example of this. You don't just iterate over them and do the same thing with every value. You usually pick out specific fields from the object and use them in your UI. So an object in the OOP sense is sort of an extension of the idea of records. It's a record where some of the fields are functions that can access the record's other data fields. It's a computational value combining state with behavior. So we saw one of these in the previous example. So the image field from props has this URL method that you give it a name, and it can generate you the right URL for that image size based on the name of the image in the object. But sometimes we see, depending on which sense you're using an object, the rules that we gave before about adding and removing fields sometimes won't apply. So if you've used Webpack to build your front-end assets, you might have run into this where if your Webpack configuration contains a field that Webpack doesn't recognize, you'll get an error. And all that we've done here is we put a field in our configuration object that Webpack doesn't use, but it's not ignoring it. It will actually throw an error because of that. So that's the case where we've added something and it's broken the program that's consuming this value. There's a good reason that Webpack does this, and that's that it's a sort of interactive user-facing program, and if it sees a field it doesn't recognize, it's more likely that that indicates a typo or a mistake or something that's not supported if you've just done a major version upgrade. It's less likely that that configuration was generated dynamically and just contains extra stuff that shouldn't be there. It's much more likely that somebody wrote that key by hand and they typoed it. So in the same way that command line programs will usually throw errors when you give them options that they don't recognize, that usually indicates like a typo or a programming error when writing the script. Likewise, if you are using an ORM and you try to save an object into a table that doesn't have a column for that property, what should happen? Do you want that to just be silently ignored? That's probably undesirable. So yeah, ORMs will typically ask you to say, well, these things get written to the database, and these things are just extra stuff that happen to be on this object, and they're part of its runtime behavior, but not part of its persistence. So what we've discovered here is that the values in programs embody quite a lot of conceptual complexity, especially if it's not clear like what computational concept they represent. So a really good example of this is that, I think it was just last year, no, I forget exactly when this happened, but at some point TC39, which is the committee that is responsible for the design of the JavaScript language, had this proposal to add a flatten method to arrays. And this caused a huge big argument, and part of the reason it caused a big argument is that an existing library that had been out in the wild for a decade or so had already implemented that method, and the implementation that TC39 was proposing didn't agree with the implementation that was already out there in the wild. So they were saying, you'll break our website if you put this new method in the browser. And beyond this being a sort of, these things are like, spec fights are always a good source of arguments. It's worthwhile exploring like why this argument was even necessary. And part of the reason why it's necessary is because the concept of flattening something is too complicated. So what do we mean by that? So one way that you could implement flatten is to reduce over the array and concat all the elements together. And the way that JavaScript's concat method works means that any arrays that are inside the outer array will be concatenated together. So this has the effect of flattening an array to one level deep. It removes one level of nesting. Now, that might not be what you want. It also might not include several other things that you do want. So for example, if you have an array that contains lots of different kinds of things, particularly other kinds of iterable things like strings or sets, what should be the effect of that? Should they get flattened as well? What if the set contains an element that is already present in the outer array? Should that get kept or thrown away? Like, the properties of that set get thrown away if you expand the set out? What's the effect of null? Like, should the value null end up in the list, or should null get turned into an empty array and get flat mapped out? Like, there are so many questions you could have about what this function should potentially do, depending on whether you consider these things to be flattenable in some sense. And that ambiguity means that there's a huge space of possible implementations of this function. So if two people write a flatten function and you put both of them in the same program, it's quite likely that they won't agree with each other. And so that will lead to inconsistencies in the program and likely lead to bugs. So if you, typically if I get tempted to use this method, I'll usually sort of stop to think what I'm doing in a bit more detail. Like, if I know that I want to remove one layer of nesting in something, I'll typically use flatmap instead. Or if I know that my data structure is arbitrarily nested, I probably want some sort of recursive procedure. I'm doing an interpreter or a visitor or something. If I don't know how deeply nested my data structure is, then I actually have a much deeper design problem that I ought to fix first. So this function has always seemed like a sledgehammer to me, and because of this, I can never remember what it does, and I'm never sure how to use it properly, and I always pick something more specific. So this is what I mean by it contains too many concepts to be reasonably implementable. So sometimes that ambiguity has quite serious consequences. So a problem that occurred in Node in the last couple of years is that Node contains a class called buffer, which just gives you like blocks of memory that you can read and write to. And if you instantiate it with a string, it gives you a buffer that contains the UTF-8 bytes for that string. And if you instantiate it with a number, it gives you like a buffer that's that big. And there was a problem where in some WebSocket servers, there was some code that was not carefully checking what it was doing, and it was passing a number instead of a string. So like you sent it a message with a number in it, it would turn that message string into a number and then feed it back into something else. And that would cause the server to leak. So when it gives you this memory is like uninitialized. It could contain anything. So that caused the server to leak arbitrary memory, and is a serious security problem. So this is a problem of this function being overloaded, having too many uses, right? It has wildly different behavior depending on what you pass into it, and it's really easy to accidentally pass the wrong type of thing if this thing is dynamically generated somehow. So we fixed that by splitting this into two distinct functions. There's now a function called buffer.from, which takes a string and returns you the bytes of that string. And there's buffer.alloc, which gives you a zeroed out block of memory that is that size. So we've now removed this ambiguity. The user is saying exactly what behavior that they want, rather than the function being called trying to guess what they meant and potentially doing something dangerous. So yeah, these ambiguities tend to be quite a large source of bugs, particularly in dynamic programs. So we've looked at some of the dependencies that we have on the values that functions return to us, but there are also implied dependencies, implied contracts between the values that we pass into functions and how those functions use them. So let's say that we have, let's say that I've written this contains function that takes a list and a value, and its purpose is to tell you how many times that value occurs in the list. So I'm going to implement that by initializing a counter to 0, using a for-of loop to iterate over the list, and every time that I find an item that matches that value, I'll increment the counter, and then I'll return it at the end. Now, because this uses a for-of loop, that means that it can work with any kind of iterable value, not just with arrays. So it can work on strings and sets and maps and all the other iterable things in the language. And somebody has picked this function up and they've not looked at its implementation. They've just started using it and sort of like trying it out and seeing what they can do with it. And they notice that it works with sets, right? So if you instantiate a set and pass it in, you only ever get the result 1 or 0 because sets can only contain one of each value that they contain. But that's enough to tell whether the set contains something, so it seems useful. So someone goes ahead and starts using it like that. So then one day I decide, oh, I don't like that implementation anymore, I'm going to change it. And I replace it with this more sort of functional style thing, where I use the array filter method to filter the list for elements that match the given value, and then I just return the length of the result. So with arrays, that still has the same behavior that it did before. So yeah, given an array, it will still return me the value 2 just as it did before. But now if I pass a set into it, I now get an error. So the program's rejecting a value that it previously accepted. And the error message that you get from that is not super clear. Like the words list.filter don't relate to anything I can see here. That's an error that's coming from the internals. So from the user's point of view, it's a bit sort of opaque. But anyway, so the point is that my change of implementation has broken the user's program, and that's because the first implementation that I wrote happened to work with a wider set of values than I was intending. So then when I changed the implementation, again, just thinking that the function should only take arrays, that broke a lot of use cases that people had for it. So being an imperative language, JavaScript doesn't just involve calling functions and getting values back. It also has side effects. And this is another source of potential breakage in our programs. So one example of that is, like, let's say that I have a function that adds a dependency to my package.json. So it reads the file, parses it, adds a new thing into the adds a new package into that object, and serializes it and writes it back to the file. And let's say that I'm doing some debugging, or I want to print some output for the user, and I just add a console.log line at the end. Should we consider that a breaking change? Well, again, it depends. If you're looking at this from a sort of typed functional viewpoint, like, yes, this may indeed change the type because the program is writing to the terminal where it wasn't before. But in an untyped context, you can even still argue this is a breaking change, even though that ostensibly doesn't have any effect on the rest of the program. This program's output might be being sent to somewhere Like if this function is embedded in a program that produces JSON output that then is consumed by something else, the presence of that line in the output is going to break whatever's reading from it. So there are all these different places where these breakages can occur, all these different system boundaries. Likewise with event emitters, so one way that JavaScript is really sort of plays a bit fast and loose is that it lets you call functions with more arguments than they were expecting. So let's say I have an event emitter that's currently emitting one value with this change event, and I decide to add a new value, like the current time. That ought to be fine, because any function that wasn't expecting that argument should just silently ignore it. But actually, it turns out that somebody was using a variadic function to listen to this event, and they're expecting to get a list of things that are all the same, and they'll get processed in the same way. So again, if you're looking at this from a sort of typed language point of view, yes, this would have changed the type of the function because I've added a new thing to it. But like JavaScript's runtime won't complain about that. It'll let you do it, but the function that's listening to the event will break somehow. So what we've seen here is that, sorry to pick on JavaScript, but it's what I know. So it's very permissive. It lets you get away with all sorts of stuff that other languages might not allow. It often gives you very unhelpful error messages, so it's often quite hard to tell why your program isn't working. And that's if you get an error at all. You might be doing something where the runtime just sort of silently does the wrong thing. And there's also no way to signal to the compiler like how you intend people to use it. There's no way for me to say about that contains function, like, you should only pass arrays into this. Like, the implementation happens to accept other types. That's not what I meant, but I had no way of like mechanically signaling that in any way. So having spent 20-something minutes complaining about computers, let's talk about what we can actually do about these problems. So one common answer to this that's evolved over the last few years is semantic versioning, or SEMVer. And this is a convention where you use version numbers that are composed of three parts: the major, the minor, and the patch element. So if you make a breaking change to a module that you're releasing, you increase the first number. If you add a new feature in a backwards compatible way, you increase the second number, and if you're making a bug fix, you increase the third number. And this is supposed to signal to your users like what type of change has been introduced. Are you essentially maintaining behavior but fixing bugs? Are you adding new behavior, or are you potentially taking existing behavior away? And that's not an unreasonable proposition. I mean, it conveys a bit more information than just a sort of opaque incrementing integer or a date stamp. But it's still very coarse-grained. Like if you take something that is the size of, say, Rails, if Rails decides to break one function out of its huge API and do a new major release as a result, there's a very good chance that I'm not calling that function and my program will be just fine. So it'd be nice if there was a way where I could do something a bit more fine-grained to go, I know you've changed this thing, but my program isn't calling it, so I don't actually care. So there are some ergonomic problems with it in that sense, so that it's still very coarse-grained. And it also can't model, there are several types of changes that it can't model at all. Like if I decide to completely rewrite a library, but try to maintain its interface, so I completely change the internals, but the interface stays the same, I don't know how to version that in SEMVer. Like, ostensibly, like, that doesn't fall into any one of those buckets. It ought to be a drop-in, I want it to be a drop-in replacement for people, so it's not a major change. I've not added any new behavior, so it's not a minor change. And I haven't, I mean, maybe I fixed some bugs. Maybe the reason I was doing the rewrite was, in order to make fixing some bugs easier. But, sometimes you just, it's a performance improvement, or you just decide it needs re-architecting or something. So there's several kinds of change that this system can't model very well. The other thing is that, like, in practice, a lot of the time when I see breaking changes show up in production, they're in bug fix releases. So one instance of this that we had last year was that, so in December, at the end of 2016, zlib released version 1.2.9, which is the first release that they'd done in 3 years, which gives you an idea of like the resources available for maintaining even something as widely adopted as zlib. So the Node.js project bundles zlib as one of its dependencies. And in April 2017, they released a couple of versions that contained that new version of zlib. Now, what that zlib release did is that it made some values for its compression parameter that were previously accepted but silently ignored. It now made them illegal, and it would throw errors if you pass them in. So that's in a bug fix, ostensibly a bug fix release of zlib that made it stopped accepting values that are previously legal. Now, those configuration values are required to be supported by the WebSocket compression extension, so it's impossible to use this version of zlib and comply with the WebSocket spec. We found out in this process that if you pass in these particular numbers, zlib just ignores them, but like when you're doing the negotiation to figure out what compression ratio to use, you are supposed to say that you support those values. So we had this problem, things were blowing up, people's servers were crashing because they were receiving messages that zlib would explode on. So a few months later, we detected that problem while we were preparing a new release and doing the pre-release testing. We found this wouldn't work on these new Node releases. So we reported that to the Node project. Node project reported that upstream to zlib. So this issue is still open. It's a PR actually, if anyone wants to take a look at it. It's sort of debatable whether this is a bug. I mean, zlib had this thing in it for years where it was just ignoring these values, and it's entirely reasonable for it to say, actually, they're illegal, you shouldn't pass them in. But it has had the effect of breaking stuff, so it's very much up to debate what should be done about it. A month after that, after we'd figured out how do we resolve this with the spec, with what browsers want, with how do we negotiate all this, and we'd talked back and forth and written it all up, we got some patch releases out. So this is like 10 months of activity between the bug originally surfacing and it actually being meaningfully fixed for my users at least. So this gives you an indication of the time that it takes for change to propagate through these ecosystems. It's not just about, well, my compiler says this is fine right now. It's like if you change something, that has to percolate through an ecosystem, and that's to do with how well connected people are, how they can communicate, what various companies' upgrade strategies are. This stuff just takes time. So one thing we can try to do about this, rather than sort of figuring out some new versioning strategies, we could decide to never break anything at all, which sounds extreme, and most of us have probably not managed to live by that. But some people will try and shoot for this, and I try and shoot for this with the modules that I maintain for reasons that we'll get into shortly. So one example of this is that at JSConf.eu earlier this year, Ryan Dahl, the creator of Node.js, gave a talk about his biggest regrets about the design of the project and what he'd change if he did it now. And during that talk, he said, it's my fault and I'm very sorry. Unfortunately, it's impossible to undo now. So yeah, there are these warts in the thing, but we can't really change them. Too many programs are using them. If we change it, everything will break, so we're stuck with it. And even though a lot of, I'm not running a project that's of that scale of usage, I still try to think about that of, is it worth the time of people that are using my software that will deal with it breaking compared to my time for doing something that's a bit more convenient for me. And it's also to do with the logistics of what kind of projects I'm releasing and how they're consumed. So these are sort of fairly small little network protocol libraries. And they're very often not things that application authors are directly installing. They're usually transitive dependencies of something else that they're using. So there are usually several intermediaries between me, the author of, say, Fay WebSocket, and whoever is writing the application that depends on Webpack Dev Server. This means that I don't have any way to communicate directly with the people that are using this software to tell them what I'd like to do and ask them if it's okay and can they upgrade. They typically don't even know that they're running my software at all. It's just something that's inside something else they're using. They don't even know it's there. So I typically try to take the same approach with my own dependencies of because I'm not able to be in direct contact with a lot of people who are using my code, I don't want myself, I don't want me to be a bottleneck on, if I make a change, that has to percolate up through several layers before it ever reaches an end user. I want my stuff to be as stable as possible so that it can just be transparently upgraded and people don't need to worry about it. And I want to remove myself as a bottleneck from that process. So I'll often leave my dependencies sort of open-ended, which a lot of people will tell you is a bad idea. And in other contexts, I don't do this. But as an open source maintainer who does this in my spare time, who doesn't have a predictable amount of bandwidth to work on these things, I don't want someone like needing to wait for me to bump one of my dependencies because HTTP parser released a security update. I just want them to be able to upgrade and, until such time as that breaks. And there is a risk in doing that. They might release some breaking changes and break my stuff and everything downstream of that. But that just means I'm a bit more cautious about the dependencies that I take on. I'll usually try that. If I'm not familiar with them, I'll try them out for a bit. I'll sit with them for a few months, see how they change over time, and then make some sort of cautious decisions about what to adopt. So a lot of this hinges on communication. These are the kinds of choices that I make as an open source author who's doing this with unpredictable amounts of spare time to work on the software. When I'm at work and I'm in direct contact with my colleagues that are working on the same code base as me, I make very different changes because it's very easy for me to go oh, I want to change this bit of the system. I will just email or talk to whoever else that might impact. I can find out who it will impact because I know everybody that works on the code base, and I can go and talk to them and we can negotiate something, and it's a lot easier to make changes in that context where you do have that direct communication with everybody that be affected by it. So it's a very contextual thing. It's not just about the code in and of itself. It's about the set of people that work on it and to what extent they are in contact with each other. So we can also communicate through the code we write itself. So JavaScript is a very small language and it's very hard to say what you mean accurately. But it has grown a few new things recently that let you be a bit clearer. So for example, instead of an array, you might decide to use a set. That might express a bit more of your intention. Likewise, if you're using an object, we have maps now, so you can be a bit more explicit about no, this is a map. It's not a record. It's not some other kind of object. It's a map. Likewise, you can try to avoid operators and functions that are ambiguous. If you know that you're doing string concatenation, maybe avoid the plus operator and use template strings or the join method instead. And then that more clearly signals that you know you're dealing with strings and not arithmetic. You can try to avoid bits of the language that you know are brittle, and that means idioms in the language that make it likely that you'll have to change your mind later. So one example of this is if you have a function that's growing a long list of parameters. Firstly, that tends to make the callers quite opaque because you'll just have this long list of things and it'll be sort of unobvious what any of them are for. But it also means all the callers need changing every time you add a new parameter. So a nice way of dealing with that in JS is to sort of replace that with object destructuring, so you can sort of simulate named arguments this way. And that lets the callers just pass in the things that they care about and everything else has a default value. And that means whenever you change the signature of this function, you don't have to change any of this in callers, and they're easier to read. So it's less like you'll have to change your mind about how things work. This happens with functions that take callbacks an awful lot because typically the callback wants to be the last argument to a function. So if you want to add a new parameter to a function, like say we take this get function that we saw earlier. Let's say I want to add, let this take a list of headers. I'm going to put the headers parameter before the callback, but then I'm going to need to do some mending up here and go okay, well, if a caller isn't passing that extra parameter, that means it's passing a function in the second position. So if that's a function, then do some reassignment and then do what I was going to do. So it adds all this sort of boilerplate of dealing with legacy callers. If you're using promises, that's a lot easier because promises don't pollute the parameter list of the function. So it's a lot easier to add an extra parameter with a default value and the body of the function remains pretty much unchanged. So you can use errors to communicate with people. Like we saw earlier how JavaScript not raising errors in certain situations isn't helpful. Errors, as anyone who is a fan of statically typed languages will know, errors are supposed to be your friend. They're supposed to help you write working software. They're not just there to yell at you and make you feel bad. So for example, I could have put an assertion in my contains function that said, you're supposed to call this with arrays. And then I'm more free to change my mind about how it's implemented. So this is from some code from some security code that I maintain. And this like one of my favorite bugs that's come up in the last couple of years. So there was a potential bug here, which is that, so pbkdf2 is a key stretching function that just like takes some data and returns you a big blob of pseudo-random stuff. And its bytes parameter is supposed to be an integer, but not all integers are divisible by 8. So sometimes bytes will be a fractional value. Now until node 9, that was fine. Node just rounded the number down to the nearest integer. And that was okay because this was actually generating a lot more random data than we strictly needed. So it's fine if it got truncated a little bit. But on node 9, it started throwing errors and going, keylen is out of range. Well, I don't know what keylen is. This is misreporting the error because it's not that it's outside these boundaries, it's that it's not an integer. So this is just a sort of badly designed error, right? So this is one of those cases where like you need to pay attention to like really what has gone wrong and how can I tell the user like why that's wrong and what they can do about it. Likewise, if you're especially in like dynamic language spaces, it's really common for people to sort of play around in the REPL and look at your stuff and see how it does. And if they can see all the internals of something, like you can in the developer console, people get prone to sort of digging around inside of objects for stuff they might want to use. So you might end up with this sort of long chain of where you got this client object and then you dug around inside it until you found this socket and it let you send something. But we have this convention in JavaScript that if you're prefixing with something with underscores, it's private. So that's a signal to the user that they're doing something that like is likely to break later. So there are conventions that we can use, whether they're enforced by the compiler or if they're just community conventions that sort of help the code communicate its intent better. We can look at the way that we write documentation. So like often when I write readmes for these modules, I'll try to provide sort of complete self-contained examples as well as sort of textual descriptions of what the thing does. So very often people are sort of Googling for stuff, and if they land on a page, so this is just a snippet from the documentation from one of my modules, and taken out of context, if someone just arrives at this paragraph and they're quickly trying to find something, they'll probably end up with more questions than they arrived with. I don't know what a driver is. I don't know, is the URL an object or a string? I'm not sure. I don't know what these things mean. So it's really helpful to have like a self-contained, like this is a fully working example that like you can paste this into a text file and it will run. And having examples that work that way means that like once someone can get something running, then they can start tweaking it and they can see what you mean by the words in your text. You do need the text, but you need a way for people to bootstrap their understanding of the text so they can get further into it. And finally, we have automated testing that we rely on. So a common bit of advice, and this is a topic that I can't do justice to in a couple of minutes, but I just wanted to mention that one common bit of advice that you hear with testing is like, don't test your dependencies, right? They're other people's problem. But actually, I think that's a really good way of validating your assumptions. Like, if the caller of that contains function from earlier had written some tests about it that expressed their assumptions about it, then one day when their build started failing and they were getting errors everywhere because the contains function had changed, they would also have a unit test that said, yeah, the contains function doesn't do what you think it did anymore. So you've got this thing that isolates the cause of why half your application is broken. So having those signals that like where you've recorded your assumptions and you get told when they're no longer true can be really valuable. So what have we learned to sum up? So compatibility isn't just a sort of technocratic thing about the code itself. It's not just you point a compiler at something and it will say yes or no. It's very much determined by the context of usage. And that context comes from like all of the people that are interacting with that program, whether they're running it, reading about it, repurposing it, taking it apart, what have you. And you can influence that usage by the way that you communicate with people, whether that's in an open source context or within your company. The way that you communicate around the code is just as influential about how it behaves as just the text in your editor. Thank you very much.
I think we've probably got time for one, maybe two questions.
I'm not sure you do.
Oh.
That'd be a short one. Yeah.
Sorry, this might sound really harsh, and it's not meant to be, but is JavaScript still the thing to persist with when you're having to do all these jumping through hoops to try and achieve this effect?
Partly, yeah. I mean, I still write it a lot, but that's partly because I'm writing open source stuff and I want that to run on a wide variety of platforms. So it's partly about impact and portability. Like, it's good for that. But we do have an increasing choice of languages that compile to it, especially now WebAssembly is sort of on the horizon. I think there's going to be like an explosion of, you're going to be able to write Rust or whatever else you want. So if you don't find the ergonomics of the language helpful, I think we're going to have a lot more options in that space quite soon.
Cool. Thank you.